Hey guys, today we're doing chapter 9, which is on polynomial models. So we're starting chapter 9, and the whole chapter is just on polynomial models. We're going to talk about finding roots of polynomial models. We're going to do division of polynomials. And we're just going to start off with what is a polynomial model. So we're going to talk about the standard form and some different situations that you might actually use polynomial models in. So the general form is a sub n times x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2, etc., all the way down to a sub 0. So essentially, a sub n, these a sub n values are just the coefficients of your terms, and the x to the n values, notice that our n, or our exponent, is decreasing by 1 every time. So general form, you start with the highest exponent power, and then you decrease all the way down until you get to your linear term, or the term that has no x value. Okay, so in this form, the a sub n values are the coefficients and the powers are in descending order. The degree of a polynomial with one variable. If you want to find the degree of a polynomial, it's just the exponent, the highest exponent for that polynomial. So we'll do some examples later. Coefficients, those are just the values being multiplied by the variable, so those are the numbers in front of your variables. Leading coefficient. The leading coefficient is the coefficient in the term that is the highest power. So whatever the degree of your polynomial is, you look at that term, and whatever the coefficient of that term is called your leading coefficient. Essentially, it's called that because if you put it in standard form, it would be the first coefficient that you have, because it would be the first term. Monomial. A monomial is a polynomial with only one term. So that'd be like x, or x to the fifth, or 3y squared. Okay, so we've just got one term. A binomial is a polynomial with two terms, so that'd be like 3x plus 2, or 4y minus 5. A trinomial is a polynomial with three terms. It can be any degree, so that could be like x to the fifth plus 2x plus 1, or 3x squared minus 2x plus 5. Okay, those are all trinomials. You can also have a degree of a polynomial more than one variable. So let's say you've got x's and y's for your variables. Well, when it's in more than one variable, you just add the exponents together, and whatever the term with the highest exponents added together, or the sum of the exponents, would be your degree of your polynomial. So let's do some examples. Example 1, we want to find the volume of the cube, and we want to put it in standard form. So I know that in a cube, the volume is just length times width times height. So I'm going to multiply all these together. Alright, so starting this off, I'm just going to multiply this one and this one. So in other words, I'm going to distribute the 3x to the x plus 3. So I'll have 3x squared plus 9x. And I'm going to take that one and I'm going to FOIL it with this. Okay, now I'm going to simplify. Okay, now I'm just going to check and make sure that that's done in standard form. Remember that standard form, I need to have my exponents in descending order, meaning I start with the biggest one. That is true, what I'm doing here, so this is my final answer. Okay, what is the degree? So remember, the degree is the highest exponent that you have. So in this case, my degree would be 3. What is the leading coefficient? The leading coefficient is going to be the coefficient in front of your highest x term. So the coefficient of x cubed is 3, therefore my leading coefficient is also 3. Then we have when x equals 10, what is the volume? Well, I know that this is the equation for my volume, so if I plug a 10 into that, then I can go through and simplify. Okay. So that gives me 5,850. Okay, next up, you're saving money over the course of 4 years. Suppose you can earn 3% annual interest compounded annually. If you deposit $1,000 on January 1st of the first year, $500 on January 1st of the second year, $2,000 on January 1st of the third year, and $1,000 on January 1st of the fourth year, how much money will you have at the end of 4 years? Okay, so this is a little bit different than the compound interest problems that we've done before. The difference is that normally we talk about investing a set amount of money and we just leave it in and we don't touch it. So we don't add anything, we don't withdraw anything, we just leave it in the account and let it sit and earn interest. But you'll notice that in this problem, we're adding different amounts of money every year. So we're adding to these accounts. So the best way to approach a problem like this is to think about each of these years as separate accounts. So one account will be this $1,000 that we deposit, and we know that that's going to be in the account for 4 years. This $500 will be another account, and that one's only going to be in there for 3 years. And this $2,000, well, we deposited that on the third year, so it's only going to be in there 2 years. And $1,000, we deposited that January 1st of the fourth year, so it's only going to be in there for a year. So what we can do is we can actually represent this with a polynomial model. So I can write for my first account, which I deposited $1,000 into that account, I know that that's earning an interest rate of 3% compounded annually, so I can write it's multiplied by 1.03 because it's going to increase by 3%. And that is going to happen for 4 years. Okay, then for my $500, well, that has the same interest rate, but that one's only going to be in there for 3 years. Okay, for my $2,000, that also has the same interest rate, but that's only in there for 2 years. And finally, for my last $1,000, that's only in there for 1 year. So when I go through and work all this out, I end up with $4,823.67. All right, and that is everything for section 1.